To facilitate this session, I'm going to invite none other than our director at the Center for Biomedical Innovation, Dr. Pujital Silva. He's a senior lecturer at the Biomedical Engineering at Department of Electronics and Telecommunication Engineering at University of Moratuwa. He received his PhD from University of Queensland, Australia in 2005. His current research interest includes soft and hard tissue biomechanics, and a lot of what you have seen presented, he himself has supervised today. Polymer-based biomaterials, wearable sensor-based motion capturing for rehabilitation and sports analysis, and engineering education. Before moving to research, he worked nearly 4 years in the industry as a mechanical design engineer. He received his bachelor degree of engineering from Queensland University of Technology in the year 2000. So today at this last section, what we want to see is how can we collaborate? How can we as SEBI collaborate, form collaborations, how can we attract those with funding to carry this work forward? So over to you, Dr. Puji.
Thank you, Dr. Nailin. In facilitating this last session, I think it probably is probably the most important bit for me in terms of trying to understand where we all stand in relation to this issue of affordability. So affordability probably becomes less affordable now if you take the Sri Lankan context and if you really look at where the Sri Lankan rupee is heading right now. But affordability can also be seen as an area of not having access to people who are able to do things. So one of the key, I think, the bridges that I would like to cross, or to the gap that I'd like to bridge, I would say, is by allowing clinicians to talk to engineers and us to be able to kind of have an open dialogue about the problems that we want to solve. Because motion capturing in itself is not going to serve anything unless we actually have valid problems. So be it in sports. Now, Germany brought up something very important about the type of sport that we can excel in. In the same way, there are clinical issues that we might actually be grappling with, for which we might not have a proper solution. So Mr. Gopi, what I appreciate about Mr. Gopi is that he focuses on cerebral palsy and that need. He's able to understand the specific needs for which equipment, technology, motion capturing can provide a solution. So one way to probably move forward here is, I feel, is to identify the problems that we are trying to tackle and the problems that we are trying to solve. So from an engineering space, we might be able to then understand what solutions might be there. And that might be one way to kind of bridge the gap. So that is, so the center's role is actually to facilitate this process. Now, yesterday we had a workshop where Professor Saroj, one of, I think if you're a clinician in Sri Lanka, you probably know him. He's a professor in clinical medicine. And, you know, there is currently a device that's been manufactured for endothelial dysfunction. So it's basically a device that measures your likelihood of getting something like a coronary disease later in life by measuring the quality of or the health of your endothelial, the layer. So that is the layer that sort of lines the blood vessel, and that initially came as a problem that was out in research, and that got investigated in the university, and out of that came an initial result or an outcome that then took, I mean, the team was able to take it out into the market, and today it's been developed as a commercial solution. So motion capturing solutions, I believe, can fall into that same category, provided we have, you know, particular problems to solve. So that is probably where I would like to open up this discussion to invite different people who may have different problems or who might actually be representing different disciplines or different areas, industries, to come forth and maybe sort of contribute as to what those problems might be or any other ideas, suggestions they might have. Okay, so I understand there are a number of clinicians who are joining from, I think, Cambodia, Thailand, in a few countries, neighboring countries from Sri Lanka. Um, what might be the interest for you in a workshop like this? In what ways do you think this workshop might be able to facilitate a solution to a problem that you might be having in your part of the world?
We do have a question here. If you want to unmute your mic and speak, please feel free to do so. But I'll read it out. What are the current research opportunities that we have in Sri Lanka to develop the best wearable technology, as in garments and textile, for sports? How can we connect with SEBI to do research?
So that question is what sort of research opportunities are there?
What are the current research opportunities for developing wearable sensors with textiles for sports, and also how they can connect with SEBI to do research in future?
So the research opportunities are always there. Most of the time, what we don't actually have is the funding. So even I mean, what I would say is it's always important just to have a dialogue and just to be able to figure out what is it that we are trying to do, or how are we trying to achieve that, and then maybe look at a plan of action. So even funding, I would say, is available if we know how to tackle that issue. But whatever because I mean, from our university's point of view, when it comes to the medical side, what we do is we focus more on developing the technology aspect. But those technologies are only as good as the problems that we are going to solve. That's what I feel. So just as an example, if I mean, you heard about the journey of Kairos sensing. Really, what it actually started off with was we were trying to develop a technique for detecting chucking in cricket. So the very thing that Mr. Udana Bandara talked about, we were trying to do back in 2000 and I think 15 or 16. So then that gave us an opportunity to work with Sri Lanka Cricket, and the research team was able to come up with a suitable solution. So it was just a prototype, with wires hanging and all that. But then once it appeared to work, that gave us an opportunity to then engage with Sri Lanka Cricket on a more I would say, a more serious sort of a level to try and develop it. Now that the project didn't go ahead, but that was the beginning of what gave rise to even the idea of Kairos sensing. So a few years later, of course, we had a lot of setbacks and a lot of things, and we moved on from sports to biomechanics or the gait analysis, because that we felt was a greater need. But then that is how it happened. We were trying to solve a problem, and that gave us the opportunity to try and develop a technology and move in that direction. So in answer to that question, what I would say is, if you have a problem that you're trying to solve, let's start there and see what technology can do, and and that way we can move towards developing wearable sensors. So in sports, I mean, Germany talked a lot about how they actually analyze the player load and things like that. So many of the sports teams, who use wearable technologies, they don't use the whole body system like what we discussed. That is more for like a clinical setting, but they use a single sensor. So in that sensor, they are able to capture the much of the player-related performance indicators are able to be captured through a single sensor like that. So these are the opportunities that are there for us to, certainly there are a lot of opportunities that we can try out, but we need an interested party to come with the interesting question. And I kind of keep repeating myself on that issue. Um, so
If you
metabolic, you're talking about the metabolic expenditure, isn't it?
yeah, I mean total energy expenditure, like how long they travel and how long they what are the distance they cover during rugger match. With that we can enhance their nutrition values, and I think it is not a big thing to develop. If you are interested, it is, you can by using the this wearable GPS and the wristband and like that. I know there are softwares in the outside the country. Yeah,
Chadura, like for answer your question, when it comes to the energy expenditure, it's like broad topic you're talking about. So there are different types of energy expenditures that we have. So simply, normally nowadays, even mobile devices, it can calculate how many steps you have per day. And even if you remember, Mr. Ranavira said, like through the GPS system, you can track how far they ran throughout the rugby game and all other stuff. So there are possibilities that you can measure their physical energy expenditure, and so then you can measure it up with the nutrition factors, how much energy requirements they do need. And when it's come to the nutrition, then it's, again, I'm not expert in nutrition, so you better to get a solution from them to have an, as you said, nutrition plan or something. If in that case you need to have the metabolic rate of the person to person, it's maybe different person to person. So I'm not much expert on that field, but I know that it's going to be different to person. But there are systems even in Sri Lanka, you can measure how far they have run, how far they have gone. I think in Sri Lanka cricket they also using GPS system, or maybe IMU, I don't know, but even you can measure it, how far. For example, in my sense, if you want to check a boxing fighter or maybe karate player, how far he moved throughout the one fight, you can measure it. Even my gut feeling is you can measure it from IMU system too, especially GPS system, as Jamini told. I think he can expand the answer. Jamini.
Yeah, I'll just share my screen if it's all right, please. Can you all see my screen? Hello?
Yes, we can.
Yeah, okay. If I just go back to this slide and then talk about that. So basically you have to understand in terms of these external as well as internal training loads. To answer your question, mainly external training loads are measured with these kind of parameters that you can see below, like sprint efforts, VHSR efforts, high-speed running efforts, Excel, so likewise, right? So this is mainly based on the GPS, and then we have internal measures as well. So mainly it's heart rate, but getting the internal measures is kind of challenging. Therefore, what you find more in applied setting is things like more response kind of measures. So these are things like RPE or fatigue scales. You can have a look. So it's like a player would do a session and then he would give feedback based on a scale, which is proven to be accurate. But to answer your question specifically for metabolic as well as this energy expenditure or nutrition aspect, there are wearable sensors. I can get back to you if you're interested to measure certain those kind of measurements as well. But mainly it's mainly controlled via nutrition. He would look at the new diet plan of a player, getting that feedback on certain occasions. They would use some wearable sensors. I hope that answers the question. Thanks.
yes, thank you very much. I'm a sport medicine trainee, so we can manage that nutrition aspect, but the problem is we couldn't get the correct and accurate data on their energy expenditure. If you can bring these things into the ground level, the lot of athletes and the players will benefit these things. Thank you very much.
And also to add that one, recently one study going on in UC Rise. So they're looking at this energy expenditure, how it's changed with the humidity and the climate, so with the temperature. So it's another new research. If you want, I can find some information and pass it to you.
So thank you. Miss Vidanage or Dr. Vidanage, would you like to voice your comment directly? Perhaps mic is now,
Yeah.
okay, over to you.
Yeah. So actually, I'm a clinician representing the physical rehabilitation of the patients, and also with this, within your online workshop, the future coming rehabilitation consultants. Also, two of them are with you, Dr. Naomi and Dr. Sachidra. So in my field, actually, I would say almost everything in the physical rehabilitation, we need to address with the biomechanical analysis, so which will help to improve the treatment outcomes of the patients. For example, children with cerebral palsy. So we go for a lower limb orthotics and try to manage the lower limb gait biomechanics, but we do only the observational gait analysis. And then we go for the fine tuning of this orthotic management and then the physiotherapy. So actually, if you can involve more in the clinical field, like rehabilitation sector in Sri Lanka, physical rehabilitation is quite lags behind the other curative, preventive, and the healthcare sector. So if you can involve in more in the physical rehabilitation of the patients, I think it would be much more like beneficial to the Sri Lankan people with the disability. So that's what I wanted to tell you all.
Yeah. So thank you, Dilani. That comment is very well received. And I'm not trying to push a solution, but as you have seen, the Kairos system that we are developing, the walk sense, is specifically for rehabilitation related related work. So what we're trying to do is to extend it in a way that people who want to do research can also use the same system and then start working with the raw data and then be able to do some decent work with it. So in that sense, I really want to invite the universities to kind of start working with us, because they will be able to then advance it more. And certainly the effects of that or the improvements of that will actually be felt in the clinical settings that you operate as well as a result.
Can I call upon Dr. or Dr. Tushara or Tushara, Miss or Mr. I'm not sure. Tushara, it's your chance if you want to speak. He or she had wanted to know about the resources available for motion capturing at SEBI or other labs in Sri Lanka.
So I can speak on behalf of the University of Moratuwa. We have a mechanical engineering biomechanics lab where we have I think it's a optical based motion capturing system, and it's a recent one. It's sort of being kind of being developed, or I would say it's been customized, to be able to do these studies. The other thing is connected to our center. You saw Mr. Kitmin Vikramasinghe. He showed these sensors, wearable sensors. So you can purchase the sensors, but what we have done is we have built the algorithms in a way that it can be converted to gait angles. So that is one thing. And the other benefit there, as he showed, was that we can also get surface EMG data out of those particular sensors. So those are all for research. And the third one that we are developing, as I mentioned, was the product that we can hopefully, with this accompanying software, be able to bring that. So those are the three things that I'm aware of. But as Mr. Udana mentioned, I think in Sabaragamu University, I think they also have a, was it a Colsys system or a Vicon system?
I think they do have Vicon system.
Vicon system.
I'm not pretty sure whether it's operating or not, but I'm 100% sure they do have Vicon hardware system. I'm not pretty sure whether they have Nexus, which is we need to, as I said in my presentation, we need to have the hardware system, which is Vicon or Analysis, and also we need to have the software. That is a crucial part. So in the Vicon, there are few different softwares like for engineering purpose, life science purpose, and the internet purpose. I'm not pretty sure whether Sabaragamu University have that particular software, but I have seen that they have recently purchased Vicon camera system. I don't know how many cameras they do have. So yeah. And also to adding this thing as in the sport context. So as I'm doing the joint stiffness and whole body stiffness for how it relate to the cricket fast bowling. Currently, most of the research have done with the joint stiffness and low whole body stiffness with running mechanics. So it have found that having higher stiffness in the knee, they reduce the collapsing their body during the landing phase. So how they measure the center of the vertical displacement of the center of gravity. So measuring how it worked to the with the joint stiffness. So displacement of the center of gravity we can measure through the IMU system, as per my understanding. If I'm wrong, please correct me. Per my understanding, so we can use that system to Sri Lanka. We no need to have a higher, like huge, expensive optical system. But if we can measure the movement of the center of gravity in the vertical axis, so then we can apply into the running mechanics. So far the studies, they have found that those who are having higher stiffness have a better running mechanics. So I think that is one of the practical way that we can use these systems to in Sri Lankan context. And also my suggestion is, yes, it's so it's somewhat difficult to afford those systems, but the research article that I shared with you at the last, so they have compared with the Vicon system with OptiTrack system, which is, I think in Sri Lankan money, it would be around 30 lakhs. So still, I think affordable in the university context, or like, in the big organizations. So, but what my personal understanding is, even it is difficult to purchase, or difficult to, it is not affordable. We better to understand, we should better get the knowledge how they have done, and you should read the research papers and think how those systems have been used. Then we can find the solution in its more engineering process. I have no idea about it. So then we can think what sort of things we need. As example, in the cricket fast bowling, if you want to check, analyze the legality of the bowling action, it's very short period of time. So when the arms come to the shoulder level and ball release, so it's very small period of time, very quick movement. So if we understand what's happening here, then we can find a solution, alternative solution in Sri Lanka.
I think we can measure the kinematics, but measuring the kinetics is another challenge.
Yeah.
So as you saw, there are different ways in which we can try to measure the kinetics because we can't measure the ground reaction force.
Yeah.
But
it's still through the IMU system, still we can measure the change of the center of mass of the body when they're running.
Yeah, so there are ways of doing it, but I don't think it's a well-established practice yet.
Okay.
So areas of research, but certainly like we can, if we are comfortable in starting to use these biomechanical models, so then from the kinematics you can actually then do the inverse kinematics and get the actual forces, so torques around joints and things like that, you are able to estimate better. So those are the options that are available at the moment, I would say.
Yeah.
The Institute of Sports Medicine is actually, I mean, it's the building. Anyway, they are going to establish a biomechanics lab. So they have called for tenders and all of that. So hopefully within the next, say, 2 years or so, because that space is again available, once the equipment come, they will have a fully functional biomechanics lab. So there is some good news in the horizon. So again, keep your research questions alive. And our center can certainly help connect you also with certain, I mean, at least from the engineering point of view, with people who might be able to contribute. So that way we can collectively do research and fully utilize this facility that's going to be available soon.
If I can just add in terms of cameras, so I've got 2 private clinics that I use OptiTrack cameras. I use the Flex 3, which is cameras, which is $600 US, one camera, and I use about 10 cameras. So that will be about $6,000, and then I use the Visual 3D software, which is $15,000. So I was able to set up 2 clinics, which is about I don't know, $20,000, and I use the 3D data for a medical legal cases, work cover, and so on. So if you want to use a very good motion capture, the cheapest that I was able to was with optical reflective markers is about $20,000, including the software and hardware.
Sorry, I lost my connection. Dr. Noelin, how are we doing?
I think we're good. There are a few people who have expressed interest in collaborations, and I've given them your phone number. And yeah, we're hoping that this is the idea for Sri Lanka to move forward, that this research aspect will also get developed and some practical things will come out of this session.
Yeah.
So thank you again all for coming, and looking forward to continuing the conversation as we move out of this workshop.
Thank you very much.
Okay, thank you all.